I want to talk about a project I'm going to be starting up here shortly. I've been doing some planning for it, but it's time to make a video and get into it. As some may know, I have two Heathkit signal tracers. Both of them are working. I had recently gotten into this one and done some rectifier work to clean up some of the hum and noise and get this one settled down. This one is in mint cosmetic condition, like museum quality, and it works really good. This one still has the original selenium rectifier, and it does work good, but I kind of stopped working on it. But it is worse for wear. The paint is destroyed. This cover would have to be replaced. There's some bending in the metal, and the probe is gone. I just got a piece of wire hanging out for testing purposes. Basically, this is what I'm gonna do, and I know half the people are gonna love this and half the people are gonna hate this. I'm going to take this Heathkit signal tracer and I am going to convert this into a guitar amplifier. And before I get yelled at, I'm not going to go and just simply cut this cord off and stick a jack in here so you could plug a guitar into it and call it a guitar amplifier. I have slightly bigger plans. So if you look at one of my older videos, I'll post a link above, you'll see work on a Gibson Gibsonette, a really old, it's got dual 6v6, single-ended 6v6 amplifier. And I'm looking at that schematic, and I've been staring at it for a while and looking at this particular design, and I think that I can get that amplifier incorporated into this with not too much effort. And that is to say that it's going to be some effort, but it's not going to be terrible, right? And basically the input and the first stage is going to be pretty much the same, and then it's going to come out, instead of going to that single-ended 6v6, it's going to go to that beam power tube, and it's going to come out to here. And what I'm going to do is I'm really going to keep this simple, and I'm going to build up on the design as I go along. So what I'm thinking is the first iteration is going to be extremely simple. There's not going to be any tone control or anything. I'm still debating whether I'm going to leave the Magic Eye tube in there. My wife thinks it's kind of cool, and we may go with that. Obviously, you could go with an option where you could have a jack that mechanically disconnects the speaker that you could put in the back for for an 8 ohm connection if you wanted to use an external speaker. Though I'll admit it would have to be an awfully small speaker for that little beam power tube to drive it, but it could still be a bigger speaker than this, right? So that's what I'm going with. Also, there would be incremental changes, like this whole entire knob is simply an on-off switch. So that on-off switch could move to this speaker on-off switch, and in turn, this could move to that tone knob that's found on the Gibsonette. So little things like that. Something like this, the output transformer, would definitely be deinstalled. This damage would get some sort of plate over it, and it would mask it, because there would be no value to anything below this at this point. And I guess it could be spray painted to match. It could use these original screw holes, perhaps some screw holes here, drilled out to accommodate that tube. And then, there'd be more ideas down the road that I'm thinking of for this. Another thing that I'm thinking in the future, if I could fit it in, I would need another tube, like a 12 AT7 maybe. It depends on what the budget is for the B plus, as well as the AC and the rectifier. Is if I could get like a sort of vibrato going on in here, and I would have to put I could use a second switch, because I do have a second switch to turn it on and off. I would have to add another potentiometer, and that could probably be put in right here to turn it on and then adjust it, right? So for the cost of one more vacuum tube, the question for that is, does it come at the expense of this Magic Eye? I won't know until I budget it in and then take a look with a milliamp meter, see how much current is being pulled, if it's too much or too little, and then make the decision, does the Magic Eye tube go to add the vibrato or what, and end up putting that right there. These are the things I'm thinking about. But to dial it back the original implementation is going to be basically ripping out the first stage, because the first stage of this has absolutely nothing to do with a guitar amplifier. It's built in an entirely different way, and then get it so that the characteristics of it match in its entirety as close as possible to the Gibsonette. And I'm going to have to get those schematics and transpose one over the other to come up with a hybrid, if you would. And we can see, as just a quick comparison here, this is the Heathkit, and here's the power supply and rectifier, and basically makes its way out. And here's the B plus coming down to this 12AX7. There's both sides right here. When we look at the Gibsonette, we can see the B plus coming out and making its way up down to the 12AX7 right here. And the inputs for the Gibsonette are 2 jacks. We're only going to be using 1 in this circuit, and we could see some cathode biasing right here, and some tone knobs, which won't be in the first iteration, but it'll make its way in the second, and basically makes its way out right through this coupling capacitor here, 0.022 microfarads, right? And then we're not going to worry about the final stage right here. This is the demarcation point, right, where we pass it off, right? And if we look on this diagram, we could basically see an entirely different configuration. Instead, we have a probe and noise circuit that makes its way back. Well, this is going to be ripped out, so it doesn't matter, right? It makes its way in, and this is all going to be modified. And this one, there's a commonality here, is it makes its way to this coupling capacitor, which is 0.01, right? Because different frequency response, different circuit. And that makes its way to a final circuit, a output tube, right? In this case, the beam power tube, right? So this is all going to be ripped out and modified to match this. The only thing that I want to do is more closely match the characteristics for this portion of the 12AX7 for the voltages on the plates, right? That's a consideration I want to do, because I want the 12AX7 to operate like it would in the Gibsonette, as it does, as it will in the Heathkit, right? So I'm going to be making some voltage modifications to that so that they run the same. And then I'll worry about the second half. So I'll have that other one coming across here, that the voltage isn't dropped, that would make its way to the finals. I probably won't be modifying that, because the beam power tube is set up to operate as the beam power tube should. So these are things that I have already gone through. Another thing that I'll point out is right now this one has that single rectifier. It says a silicon diode. I believe this one, however, is selenium. And this one will probably get the bridge rectifier just to reduce the hum, right? So a lot of thought's gone into this, but it's really all going to start opening this unit, snipping this cable. May not initially replace the jack, but snip the cable and just bring out the tip and ring on this as test points as I work through this. So that's basically where we are now. We're going to dig into this. We're going to rip out the noise circuit. We're going to rip out this output transformer circuit so I don't get electrocuted. And we're going to get underway with the simplest modifications possible to achieve our initial goal. I'm going to let my wife do the honors. She's going to cut the cable right over here. Go ahead, Steffi. The world is watching. Outstanding job. You did terrific. The cable is cut, and with that, the project is officially started. Now we'll open this up. It is not the first time nor the last time we've ever opened up one of these on the bench. That's for sure. And we're gonna put this into the quasi-service mode. As we do, we're gonna get this magic eye tube out of the way, which gives much room to work around the 12AX7. So push it back a little, right, and just slide that right out of there. So now I got this pigtail right here, and that sits right up into this board, and I'm just gonna cut myself a length of wire here, and that's just gonna be a test point, and that's pretty much gonna emulate the input jack for now. So for the purposes of a signal generator, it's just gonna connect right onto that. This cable right here that I got lifted is coming right off of the filter capacitor, and this is supposed to be 114 volts filtered DC. It's going straight into the noise switch. This cable will have to be removed first, and this will cut power to the noise circuit. This does, however, disconnect the 114 volts to the pin 6 of the beam power tube, because it connected from the beam power tube to that switch directly to the capacitor. And even when the switch was off, you could see that that was a direct connect, and I've severed that. And I'm not sure, because even when the noise switch is open, that connection is still there. I'm not sure if the grid, that particular grid, required that. I thought to myself, since I've cut the noise circuit and there's no danger of injecting 114 volts, maybe we could just fire this up right quick and see how the beam power tube performs without that 114 volts. If it doesn't work, I'll just re-add it, no problem at all. So let's see what we get as it warms up. We got a little green light. We could hear the tone generator that I got running in the background. But not a whole lot. You figure for the signal that I'm injecting, barely registering. So you know what I'm going to do? Let's reconnect that connection, and we're going to try it again with the same exact settings, see what we get. Okay, I ran this, you can see the red lead down here. I ran it around from that capacitor back to that position. We're going to fire this right back up. I haven't touched the signal generator, so same output. I'm just going to give this a second. Let this warm back up so we get a nice green glow. Oh yeah. So now we got full deflection. Yeah, okay, so we're gonna leave that. We're gonna move on now to the next thing. I'm gonna shut down power, we'll continue. Next piece is rather easy after all that. It's simply the removal of this resistor right here to the input of this signal cable. And that ends the circuit of the other side of the noise switch. We're gonna do that now. I think the other side is gonna be so obvious. And it's gone. Also, I've been annotating my diagrams. I've been moving along. The wire that I put in didn't require any annotation because all it did was bridge this gap that I had broken. So it fixed what was already there. The next thing I want to do is pull these coil taps out of service. This isn't entirely difficult. What I want to do is basically, you can see how the blue wire from the output coil here comes up and then meets this wire and then comes down to the tube. And basically I just need to bring that blue wire and bring it right down to the tube and forego the tap and do the same thing here. And I think the red wire, I just need to dial it back and put it somewhere where it's isolated, as I just don't want to just cut it off somewhere. I just want to make it so it's not outside the chassis. It's a center tap. So I've got the first one in place. The blue is up here now and it's disconnected from the post. I can see that red, at least right now, since red doesn't go to anything else, can simply be pulled back and dealt with later once I'm done with the other one. So just get that out of the way. Green seems to come right down and then come right back up onto the switch. So basically what I'm going to do is I'm just going to cut off the green and I'm just going to solder it back to the switch right here. I'm going to do that now. Now I've got all three cables moved off this tap. I think it's more of a safety thing than anything. I spent a lot of time working on this and I've gotten electrocuted several times. That's removed. The only thing I want to do now is just, I think I'm just going to roll this up and tape it up. I decided to just roll it up and go with a little shrink wrap. That's what I did, and there you go. So that takes care of the center tap. If it doesn't cause any issues, I could just leave it like that and tape it to another cable. So that's done. And we're going to call the deinstallation of the taps a success. This is also a good time where enough work has been done that I'm going to hook up the function generator again, and we're going to turn it back on and make sure everything's working okay. Yeah, power's on. I'm not going to plug in the magic eye tube. I just want to make sure nothing's broken. It may have slightly elevated voltages, but okay, everything's still good. So we'll shut it down. We'll continue. I'll tell you what, looking at this and looking at the original Heathkit diagram, I mean, there isn't even a cathode bias for this circuit. Well, this is something to behold. This is another piece of paper. When I look at this and it's not, you see a cathode bias circuit here for biasing this tube, and then on this side we have a 500 picofarad capacitor and this resistor here to ground, and that's just fine. Nothing about what's in this device matches this at all, one iota, right? So what I'm saying is not worried about these voltages being excessive, because I know the voltage is not going to exceed anything. The B plus coming off of here, right here, after this cable, this all needs to be clipped out in its entirety. And then it makes its way, if you can see, to this coupling capacitor. That's my demarcation point. So I sort of say that clip that off, and everything on here is the power amp, right? The beam power tube, and everything on here is the preamp. All this garbage has to come out. This is just fiction, right? And there's a volume knob somewhere in here, and this is going to be the only potentiometer for the first iteration of this, right? There's not going to be any tone control yet. It'll be a set value, a set passive component that's going to go in there. But I just can't see working on this. This is just clip it out and start anew. One saving grace though, the volume knob is a 1 meg pot, so it looks like that one can stay. If I get another 1 meg pot, that would make a good tone knob. I started ripping stuff out. Once I rip stuff out too, also I'm going to disconnect the speaker switch, and I think I'm going to make that the power switch that time while this is all cleaned out and an easy place to work on. So I'm just starting to chop everything away here. What I don't want to cut out is the heaters. So I have to be very careful I don't cut out the heaters, because those are definitely not being modified. So that's another thing worth pointing out though. But all these little passive components, all these values are going to change anyway. I'm not going to be using the original values for any of these. There's no point in trying to work around them. It's not worth anything. Make it go away. Well, I must have been angry this day when I was soldering. Look at this. Cleans up nice. Another thing to point out are these tie points to ground. I can see going from this pin to that pin. I'm sure that's not going to remain either, but I'm starting to slow down. Like these two resistors here. These are the voltage dropping resistors on this diagram. We can see that they're both 100K, which means that for their part, they're equal in this setup. And obviously for this, they are not. I'm going to have to change them because I want them to be an equal value, but I don't know what the incoming voltage should be for them yet. So, don't know. And it's not something that it's like I can't go back and do it. So I'm just going to reserve judgment right now, but I'm going to come back and revisit those. Also, this speaker switch, this cable comes down here. The other side just ties to ground. I mean, that's all that is. And then comes all the way up here to the other side to the speaker and is the negative side of this. So all I have to do is essentially tie this negative side to ground, and that's it. So that seems like, not the other side of the speaker, I mean the other side of the coil here. Just tie this off to ground, and that's all I need to do. So that seems like a good way to offboard that and make that the power switch so I could remove this piece. I don't want to get ahead of myself. I'm just pointing that out. So first order of business, I'm going to build me a little cathode bias circuit. I've got me a 1.5K with a 20 microfarad capacitor. It's a 50 volt, but it's the smallest I could find. I think it's appropriate. and I'm going to put this on pin 8 of that 12AX7, and this is going to set up our bias, and this is going to be the first thing that I'm going to do, so we're going to implement this now. I've soldered the cathode bias circuit in. You'll notice that, I mean, it is put in like spaces at a premium. You can see the resistor and capacitor right there. Positive side points towards pin 8, negative side points towards ground, and I've got to connect it to that ground post right here. And the reason is this, you know, you don't see it now, but this magic eye tube has got to sit in here and it can't be obstructed, right, and then push forward. So I have to account for that when I'm staging it. So I need to make sure that I have as much room as possible. So I don't want to waste any room. So if I could fit it in, stage it, not waste any room, that's how I'm going to implement each one of these connections. Next, I'm going to do pin 3, which would be easy. Is going to be 1.5K to ground. So I got the 1.5K connection in going from pin 3 to ground. That was relatively easy. Didn't get in the way of anything. Move on to the next thing after I annotate it in the diagram. Here's a single 82K resistor, and this will go onto pin 7. And this will then connect to what will be the input jack. Right now, I'm just going to connect the resistor, and this will probably make its way to a temporary cable until I put the jack in. And yes, obviously, something like this would come straight off of the jack, like millimeters off the jack, and then something would connect off of that. Right now, it provides a good test point to be able to connect the probe onto as an input. So this is just a temporary fixture. It's not to be considered permanent. For completeness, I've even added the 1 meg to ground. Although this is entirely unnecessary, I'm not connecting it to a guitar right now. I want to stay true to form. And I've also set it up this way as a reminder so that I am able to get this magic eye tube still installed in the unit. So far, everything that I've done with the components allows me to put this back together in its original form. Remember, the challenge will come in the addition of the next tube for vibrato, if that comes into play. Makes me wonder down the road if I might in fact take this capacitor and relocate the innards of these, since we're completely off the reservation here, to somewhere else and use this spot as a means to put another vacuum tube in here. I don't know. I'm not worried about it right now. Just food for thought. So I got this 0.022 microfarad capacitor, and I'm going to run this here on pin 6 where the plate voltage is, and I'm going to bring this to our existing volume knob. This is going to be on the outskirts of the volume knob, on the outside, not the adjustable portion. And that's where I'm going to make that connection. And once that's in, I'm going to proceed from the volume knob onward. That's going to be the next building area. So I got that capacitor installed right down here. I'll probably stand it off a bit once it's fixed permanently, but right now I just want to get into place, and it's going to the edge of that potentiometer. So that is now in place. We'll move on to the next component. So the middle of that potentiometer will meet pin 2 of the 12AX7. I'll make that connection now. I could also see that pin 2 will also have a 500 picofarad capacitor. I'm going to have to dig up one of those as well. So now I got a lead installed off of pin 2, and I'll bring that right to the middle there of this potentiometer over here. Each time I do this, I don't have it on camera. Obviously, I'm cleaning up the lead that I'm about to work with. I'm pulling the old cable off, the old remnants of cable off. We now have that portion in place, and now finally I'm going to run one more wire, and that wire is going to come off the other side of that potentiometer. It's going to tie off to our common ground. My modern tester always had trouble accurately measuring picofarad, so I had to break out the Genrad. The Genrad, of course, is perfectly reliable, and it shows that this particular capacitor is about 510, 520 picofarads. That's good enough for me. I'll be able to install it now in the amplifier. I've added that ground wire here to the ground. I've cleaned up that ground, removed a lot of that material from the old test probe cable. I want to talk about what this dangly thing is right here. I just gotten through the Genrad and got this 500 picofarad capacitor thoroughly tested. But I just want to talk about this before I put some heat shrink over this and it can't be seen. Basically what I did here is I took those old resistors that were used for another application on here, and it comes out to about 700, 800K. and made a center tap. What this is going to emulate, basically for the purpose of this circuit, is the tone knob at 50%, give or take. I mean, it's not going to be perfect, but it's just going to do the job till I get a tone knob in. I'm just going to show that here right now. What I have here is the 500 picofarad capacitor that's going to be coming off here, pin 2. And it's connecting to one side of that 330, it's actually 400K cap. And then that cap is tied to another 400K cap. And then that cable is going to come down and hit the center tap right here off of that 0.022. And then finally, I'm going to take a 0.0047, tie it off there to ground to complete that portion of the circuit. Yes, and in case you're wondering, this is temporary. This is not permanent. This is the capacitor will be relocated up top, and there'll actually be a potentiometer. This is just to get things going right now until the potentiometer is in place. Finally, I added my 0.0047 microfarad capacitor to the end of this temporary tapped resistor network here. And with this, the entire 12AX7 circuit has been rebuilt using the existing coupling capacitor that's in place. I'm not really concerned about that just yet. And you can see that second yellow capacitor down there. Ultimately to be changed, but it's not going to be changed at this moment. Also, the reason why I've left all these long is this is not their permanent fixture. I don't feel like chopping these up and ruining them, so I'll just leave it long and ugly right now and redress them later. But everything should be in place for final inspection so that it could be turned up. The new test point for the function generator will be positive here and negative chassis. So I'm going to take a look. This is now going to be put on the variac for turn up since it's now experimental. I'm not going to go through the whole variac process on camera. Just note that it is safe. First observation I'm going to point out is that I wired the volume backwards. As you could tell, it's sitting here upwards of 90. That said, in this direction, there's no complete cutoff. And you can hear a little bit of that 800 hertz coming through. So this is not a problem. It's just something I'm going to redress as an issue. The entire characteristics of this sound different. It's no longer a signal tracer. It's actually an amplifier, and it sounds a lot better actually. But I'm just going to turn it up a little bit. It sounds very nice, and it does break up at a certain point, which is kind of cool because you want that in a guitar amp. But I haven't replaced the coupling capacitor, and I also haven't checked the voltages going to the plates of the 12AX7, which in this diagram show them to be equal. That's not to say that the voltage should be the same as the voltage originally, and I don't know, what we're trying to drive the beam power tube with, but I know that as far as how they want this stage going, both stages, they should be equal. The other thing I want to point out is obviously that the tone control is locked down to a specific position. So I'm going to see if I could just, I'm really driving this. I got 1/10 of a volt. I'm going to see if I could drop this just a little bit here, I got the 0.02. I'm starting to pick up noise though, unfortunately. Very much like a guitar amp would, I'll also point out that the Magic Eye is working in very much the same way it did before. The characteristics of Magic Eye working with the loudness of the unit. The most important test, of course, is to clamp the input to ground and then turn up the amp, make sure that everything internally is working fine. So I've added this cable right here from the input, and I've got it connected here to the chassis, and now we're gonna crank it up. And we're at full tilt, and this thing is perfectly quiet. That is good news. There's absolutely nothing. I would hate to take that cable off right now. So would be even better in consideration a connector that when the jack is unplugged, that it would short the input to ground, would keep an amp like this quiet if the volume were turned up. You'd use a more expensive jack like that so you wouldn't blow out the speaker. In actuality, if I were to remove this now and just turn up the volume a little, we know how that sounds. It's got that hum to it. But because I did that, we know the hum is not coming from the amplifier. The amplifier is just picking up that radiant noise from around here. So that's perfectly okay.